Massive black holes continue to amaze us, and here's a recent discovery that pushes the boundaries even further. Perhaps the largest black hole we've ever identified. But here's where it gets controversial. How do we really know we're seeing the biggest one? This discovery, made with help from the University of Portsmouth, suggests we've got a pretty solid answer. Thomas Collett, a professor of astrophysics at Portsmouth, explains that this black hole ranks among the top 10 most enormous ever found, and it could even be the largest known so far. The tricky part has always been measuring black hole mass accurately, since most estimates are indirect, often involving significant uncertainties. This new finding, however, provides a much clearer picture of the black hole's true size. The team used a clever combination of techniques, gravitational lensing and stellar kinematics, to detect the cosmic giant. While stellar motion measurements are considered the gold standard for estimating black hole masses, they usually only work well for nearby galaxies, because beyond a certain distance, the galaxies appear too tiny to resolve the area around a supermassive or ultramassive black hole. By integrating gravitational lensing, which involves observing how the black hole's gravity bends light from other objects, the researchers could extend their reach into the distant universe. Professor Collett explains that they observed two telltale signs of the black hole. First, the way it warps light traveling past it, and second, how it causes stars in the galaxy's core to zip around at nearly 400 kilometers per second. Fast enough to be convincing evidence of a supermassive black hole. Combining these two pieces of evidence, light bending and stellar motion, confidently confirms the presence and immense size of this black hole. PhD candidate Carlos Melo from Brazil's Universidade Federal do Rio Grande do Sul, who led the research, highlighted that this new method is a game-changer. It enables scientists to detect and measure the mass of these hidden ultramassive black holes even when they aren't actively accreting material and emitting energy, otherwise known as being dormant. This particular black hole resides approximately 5 billion light-years away, in a galaxy far from our own. To put it in perspective, our Milky Way galaxy hosts a comparatively modest black hole, around 4 million times the mass of our Sun. Our galaxy's black hole isn't currently active enough to produce a quasar, the bright energetic phenomenon typical of some supermassive black holes, but it's likely happened in the past and might do so again. Meanwhile, the Milky Way is on a collision course with its neighbor, the Andromeda Galaxy, with a merger expected in about 4.5 billion years. Collett suggests that the original black holes from the smaller galaxies probably coalesced into the ultramassive one currently observed. Interestingly, this discovery initially came about during a study of dark matter, an elusive substance that makes up much of the universe's unseen mass. Once they proved that their new method could successfully measure the mass of such enormous black holes, the team expressed excitement about using future data from the European Space Agency's Euclid mission. They hope to identify more supermassive black holes and understand how these colossal objects influence the formation and evolution of galaxies, especially their role in halting star formation. And this is the part most people miss. Understanding black holes is often about unraveling the bigger cosmic puzzle, how the universe's most massive objects shape the galaxies we see today. Do you think we're close to fully understanding these cosmic giants, or is there still much more unknown waiting in the shadows? Let the discussion begin.